In this video is a re-upload of the previous video only, where the derivation was slightly erroneous and also slightly not clear. So here we wish to code a value k which is less than m equal to 2 power L dash as a value which is v less than s is equal to 2 power L, where L dash is equal to n times L. This particular coding method attempts to code L dash equal to n into L bits in L plus n bits. Okay, it is based on the following as follows. We have m is equal to s power n. Okay, we determine v such that v power n less than or equal to k, which is less than v plus 1 whole power n. Okay, let m dash equal to v plus 1 power n minus v power n. This is equal to v power n plus nc1 v power n minus 1 and so on up to 1 minus v power n, which is of the order of v power n minus 1. Okay, this is the value m dash equal to v plus 1 power n. Okay, next we try and determine a value r dash such that v power n plus r dash v whole power n minus 1 plus r dash square v whole power n minus 2 and so on. R dash power n minus 2v the whole square plus r dash power n minus v is equal to m dash. This particular sequence, you will notice that you have Tn minus 1 by Tn minus 2 will be equal to v by r dash power n minus 1. Likewise, Tn minus 1 by Tn minus 2 will be equal to v by r dash power n minus 3 and so on. Right, Tn minus 1 will be v power n, Tn minus 2 will be r dash v whole power n minus 1. If you take the ratios, you will get this and so on. In general, you will find this satisfies Ti plus 1 by Ti equal to 1 by r dash square Ti by Ti minus 1. In other words, the first degree ratios, first time the ratios are not constant. However, the ratios, the second term, ratio of ratios, ti plus 1 by ti by ti by ti minus 1, second degree ratios are a constant equal to 1 by r dash square. So just like we can construct a difference table, if the first order difference is a constant, the sequence is an arithmetic progression. If the second order difference is a constant and the sum to n terms will be a polynomial of order 2, second order difference is a constant, sum to n terms will be a polynomial of order 3, and so on. We can construct a ratio table where first degree difference is a constant. It will be a function of r power n, and as we shall see, with the second degree ratio table we can construct. If the second degree ratios are constant, it will be a function of r power n square, close, and like that. In other words, if the second degree differences are second degree ratios are constant, the exponent, second order differences of the exponent for r will be constant. If the third degree ratios are constant, third order differences of its exponents for that ratio will be a constant, and so on. So in general we will have to use, we are supposed to find out summation ti plus 1, where 1 less than equal to I less than or equal to n minus 2. This will be equal to summation over r times ti square by ti minus 1. Okay, this, upon expanding, it will come up to equal to summation of r cube times ti minus 1 the whole cube by ti minus 2. This again will be come out to r power 6 times ti minus 4, sorry, ti minus 2 whole power 4 by ti minus 3 the whole cube. Okay, again expanding it one more time, we will get r power 10 times summation r power 10 times ti minus 3 whole power 5 by ti minus 4 whole power 4, and so on. Okay, as you can see, the exponent for r goes through 1, 3, 6, 10, we might expect here 15, 21, and so on. Right, so second order differences are, this is sum to n terms of this thing. This is nothing but I into I minus 1 by two. Okay, so if we come with, if we have n minus 2 terms and we keep decreasing it up to t naught, right, we will have summation 1 less than equal to I less than or equal to n minus 2 ti plus 1 is equal to n minus 2 times r power n minus 2 into n minus 1 by 2 into t naught power t1 power n minus 1 by t naught power n minus 2, right? So in general, if we have add two more terms t naught and t1 to it, and summation 0 less than or equal to I less than or equal to n minus 1 ti will be equal to n times r power n into n plus 1 by 2 t1 power n by t naught power n minus 1. So here for the purposes of our coding, we have to take r is equal to 1 by r dash square. For the purposes of our coding, we have to take r is equal to 1 by r dash square and equate it to m dash and compute the value for r dash and have up to n bits. When we have l dash equal to l into n, we could either try to increase the value of n and decrease the value of l while maintaining this as invariant, or we could try to increase L and decrease N. Better would be to find a right compromise so that we have L plus. So if we try to fix the value of L and N such that L plus N is fixed, then this would suggest if you have to maximize L dash by L, L square by 2L, maximize the compression ratio and possibly also get good coding, then L should be small and N should be slightly or it could be as many bits for N as it is for L. So either way we could try to do that. So the number of repetitions required to code a number perfectly will not be too large.